Hi, everyone. So welcome to this session, this parallel session, are in production. So my name is Enrico Deusebio, and I'm a member of the program committee. And I'll be honored and very happy to be the chair of this session. Just a couple of words about myself. So I'm currently heading a consulting firm here in Milan, where we specialize on helping clients to design, build, and operate data-driven applications. So applications that they rely on some kind of modeling. So really ranging from statistical modeling, NLP, machine learning, and so on. And of course, R is a quite central part of our work, since it really allows us to quickly introduce into our analytical pipeline some very advanced and state-of-the-art modeling, as well as build also extremely nice proof of concept like end-to-end application using Shiny apps. Beside my work, I also started in 2016 in my spare time. I co-founded an association with some friends that is called Heart in Data, and deals with the data for good business. So basically, it aims at gathering people, data scientists that they want to engage in their spare time, helping no profit to do data science projects, because also no profit should be able to do and leverage value from the data. But having said this, I think it's really time to getting started with this session. So this is a regular talk session. So all the talk will be about 50 minutes. And for the speaker, just when you have 1 minute left, I will be ringing a tone such that you know that your time is running out. For the audience, just keep in mind to double-click on the presentation tile such that you enlarge the screen and you will have optimal view. Okay, now that I think, oh no, one important point is also about questions. So there were, as in the other talks, there won't be any question between the talks. So we will pose all the questions at the very end, after all the speakers have delivered their talk in a panel, in a roundtable discussion. So for the question, please just post the comments on the session chat by putting @ and the speaker, and then the questions, such that we can gather all the questions and bring them up at the very end. So I think I should not have forgotten anything. So I guess it's time for calling on stage our very first speaker. So our very first speaker is Marcin Dubel, who is working at Epsilon Data Science, a company from Poland, which really focuses on building an extraordinary Shiny application, good for that, and helping clients to build a production-ready solution. And hi, Marcin.
Hi, it's good to be here.
I really love the title of your talk, Code. I totally agree with that.
Yeah, I think this is the very crucial thing.
Yeah. Can you try to share your screen? So I'll give you the head up that we can all see your screen.
Yeah, this is the most stressful moment. I hope that you can see this.
Yeah, I can see it.
Yeah,
and,
I should turn off my camera, I think.
Yeah, perfect. Okay, you're good to go.
Okay, so hello everyone. Yeah, I would like in this talk to give you a quick overview of tools and patterns for making production-ready R code, for making it easy to share it with your teammates and to collaborate. My name is Marcin Dubel, and yeah, I work in the Epsilon Data Science company as a data scientist and software engineer. And my main area of focus is to helping team to optimize and organize efficiently their R projects. So from my experience, what I've noticed is that there are two kinds of challenges ahead of data science teams. One is to create value, so it's their daily business and they are experts in it, so there are no problems here. But the second common area for ahead of all of the teams is to share this value, to be able to put it into production, to collaborate easily, to make it stable and scalable. And this is what I would like to focus in this talk. So I recognize three building blocks, three areas where problems can occur. So first one is that there can be different code, and this is mainly solved by the version control systems like Git. So we'll start with it. We'll start simple. There can be interesting things that you can add to this system. So we'll go through them also. The second part is the environment. So it is crucial to make sure that the system is set up in the same way, so there are the same version of packages, because otherwise there will be problems, because you can write the same code, but it will behave differently. And the third main block is the data. So usually the problems can occur when the proof of concept of the project was created using some test data, but then when we switch to production to use client data, it is just not working because some assumptions of the data are not met. So we'll go through the tools for making sure that data is okay. So let's start with the version control system. Probably you are all familiar with Git. I just want to advocate that you and your teams follow the simple rules. So first one is to use the version control in every project and from the very beginning, and use all of its features, such as branching system. This is really cool that you can work and collaborate independently. And I've seen too many projects when the team was committing directly to master, and it caused a lot of troubles. Also make sure to use informative commit messages to be able to scan through your changes and your colleague changes when you are doing code reviews easily. Also, I do recommend you to manage the task board, to split your tasks into small issues that you can work on, and having such organized way of what you plan to do really helps you to avoid writing redundant code. So the general rule here is to be always ready to collaborate with someone else. The nice extension to the repository is different continuous integrations. So this is a set of events that you can trigger automatically when some action is happening. And it's really useful, really powerful. We've heard yesterday on Colin Fay's talk how important it is to run unit tests. And this procedure can be boring and annoying when you are doing it manually. So having it implemented in the continuous integration really helps you to be sure that it happens. I would like to present here the GitHub Actions. I really like this implementation because it has a lot of ready-to-use tools on the marketplace. But in the same time, it gives you all the flexibility to build your own solution. So check this. There are a couple of links that you can follow. Read about this. This is super simple, so why shouldn't we use it? Another pro tip is about the GitHub template. I think that your organization or your team has some set of patterns, some set of rules, how you're delivering your projects. We in Epsilon, for example, we are experts in building Shiny applications, and we have our way of structuring the application. So we put it all in the template, so when we create a new repository, we can just reuse our work, and all of the teammates can collaborate easily because we share the same structure of each project. Okay, the environment, the very crucial part. So lack of development environment is the root of many errors. I can imagine that all of you have met during your careers some of those problems. So basically, you are writing the same code, but it will behave differently on your machine, on your colleague machine, and on server. And also, when you're manipulating the packages, they can affect your other projects. This is super bad. Hopefully, in the R world, we have a very simple solution to this. So Rnv. This is a package that separates your project environment so that you are, we can say, installing your packages there from the scratch, and they are totally independent from what you have in your global environment in your other projects, and so you can have a different version for each project even. This is also very useful because with the state of your environment is saved in the single RNF log file, and you can share it with your teammates, for example, through the code repository. This is a single file, human readable, and they will be able to restore environment quickly. I will show you on the next slide. You might be familiar with the Packrat package. It even has its own icon in the RStudio. But I really encourage you to use RNF. Packrat is doing a similar job, but is much less intuitive, and it's very hard to set up. And with RNF, it's super easy. RNF is supported by RStudio also, so I think that they will switch this icon soon. And also the great advantage with RNF is it's much more easier to build the Docker images when you are manipulating the R packages, because we can only make a snapshot of our environment, a Docker snapshot, and send it, for example, to Docker Hub, where it can be shared, because all the restore logic is already in the RNF log file, so we do not need to manipulate the Docker file. So with RNF, you're just interested in 4 simple commands. So you initialize it in the project, you install the packages that you're interested in, then you're creating the snapshot to save your environment into this RNF log file, which later you can push to the repository, and your friends can just, with RNF restore command, get your environment, which is also cool. It is using the global cache, so if you have already something installed, the process is much faster. It is implemented in a clever way. Okay, so data workflow, the third building block where the problems with sharing code can occur, and you won't be proud of your code. So the very important part is to keep the data process clean. I find the Drake package here very useful. It is organizing all your files, functions, results in the single plan, so it's easy to manage. This plan is a single source of truth, so you can have a mess in your scripts, in your functions, but you can always rely on this plan and check, okay, so what are my steps and what functions I'm using and what are the dependencies. Drake, I really like Drake because it is also creating a clear visual structure of what is happening, and you can share it, for example, with the business users. Nice feature of the Drake is also that it updates in a lazy way. So in this example, something was modified in the function that is creating hist object, so it is outdated. But when we rerun the whole data workflow, Drake knows which parts only to update, and the others, it can be just taken from the cache as they are. And it's really helpful when there are some heavy calculations involved. Drake will take care what to update. You do not need to worry about this. So here I would like to present you some real life example from the project that I was working on recently. So the logic is a little bit more complicated here. The green circles are the objects that we are creating, and the blue triangles are the functions. And this was really helpful because this is like a ready documentation, and I go through it with my client, who is a business user who works in Excel, and we can follow and check if the business logic, if the algorithm is correct in our implementation. It is also great for finding bottlenecks. So here, for example, the loading row data takes over 14 seconds, which is much more than any other part. And so if you want to speed up the process, you know where to optimize. Okay, the other part related to data is to be sure that everything follows the assumptions that you had when you were building the code. So for this, Epsilon created an open source package. It is called Data Validator. It's available on GitHub. Soon there will be a CRAN release. And this is a package that is a wrapper on the asserter that you might be familiar with. So you are building your rules for your data check in a way that you're used to from the asserter, and it's created a shareable HTML report, as you can see on the GIF here. And you can send this report via email, for example, to the management, and it's easy to check. So what is wrong in the data, and if it is the data can be used on the production. The process can be also automated and triggered, for example, on the RStudio Connect anytime there's a data update. The last part about what you can do in your project to speed up is how to load data, especially into Shiny. And Plumber package is really helpful here because it loads only what is needed. It is done by the REST API that allows you to connect only to those parts that you need and to load them via nice API. You can deploy Plumber easily using RStudio Connect or Docker and just use it. This is super simple. Check the documentation on our Plumber to see how easy it is. I also encourage you to use efficient data libraries such as FST, Data Table, or Arrow, and they can vastly improve your performance. Okay, so to wrap up, the 3 takeaways for 3 parts. So always use version control, use it properly, use the continuous integration, do the code reviews, follow the best practices here. Set project working environment when you're starting a new project. You can do it with Rnv, you can do it with Docker, with both. It is a must to be sure that you can collaborate with your others, but also that you won't hurt any of your work. And also organize and validate your data structure. Be sure that all assumptions that you had in code are expressed in the, for example, asserter rules, and that the new data sets or updated data sets follow them. And use Plumber and efficient packages to not overload your applications or your project with the data and to organize it clearly. Thank you. I would be happy to discuss with you those issues and other are related. You can reach me on Twitter. I publish those slides there. You can reach me via email. And I encourage you also to visit our website. There is a cool blog post part when we share our lessons learned from Shiny, from R, and from machine learning. So yeah, thank you very much.
Thanks a lot, Marcin, for your talk, for all the tips. So we can now move to our next speaker, which is Matthias Bannert, who is working at ETH in Zurich at the. Oh, that was the gong from before. Okay. Matthias is working at the Swiss Economic Institute and is working as the tech lead for the development and the operation team there. So today he's going to talk us through Airflow, Docker, and GitLab continuous integration. Hi,
all right.
Hi, Matt. Hi,
Hi,
how are
Enrico.
you? Hi.
All good. It's raining in Zurich. Thanks everyone for tuning in. So I suppose I get out of the way here and
Okay.
share my screen.
Yeah, try to share your screen and I'll just give you the head up that I can see it.
Just a second. Here we are. So
okay,
everybody should see it now. Yeah. And I get out of the way. Maybe also for those of you who experience connection problems or simply find it too fiddly within the hop-in window, I've already shared this slides on e-Rum2020 -slides.netify.app. So maybe you also want to take a look at these slides there. Yeah, as Enrico already said, I'm talking about how R fits into our production stack at our institute, and yeah, it's basically about R being a good neighbor, but it's also about R being a small language compared to the likes of Java and C++ and so on. And I think Marcin has shown already a lot what R can do and how great within like the built-in tools are. And this talk is kind of a supplement to that, showing how well it integrates with other tools, with other environments that are not strictly R. So the rest of my talk is structured as follows. First, I would like to do some terminology to make sure everybody's on the same page. And then I would like to walk you through to the major components of our production stack, come up with a little application-minded example, and then discuss how well R fared for us, and hopefully we can extend that to the Q&A session so I can also learn from everyone's experience what you are doing. Yeah, so what is production for us? We produce economic statistics on a monthly and quarterly basis. And obviously, when thinking of quarterly statistics, production thinking is not inevitable. It's not the first thing that comes into mind, but if you want to do it over decades or even over months and years, it all of a sudden makes sense, especially if you want to ensure a certain quality. And believe me, we were kind of happy that we already had a production thinking, a production setup in place when the current pandemic hit and everybody wanted to have daily, weekly economic indicators all of a sudden. A very important component to this is Docker for us. Obviously, most people in here know about Docker, but nevertheless, I would like to put a little emphasis on the first and the last point on this bullet list here, as opposed to more traditional virtualization approaches that kind of give the user the feeling to have a real server, full-fledged server environment at the fingertips. Docker is more application focused, more focused on a single task, so to say, so a more application focused virtualization approach. And last but certainly not least, Docker images can be stacked, and this is really, really important. We are standing on the shoulders of the famous giants here, especially important to beginners. There's a great Rocker project, and you can use the images that are built on top of the Rocker project, so you can spin up an API even if you have never done it before in a very short amount of time. So at COF, Docker is not really spectacular. It's a very simple setup. We use a decent sized VM as a Docker host, and to run our permanent and non-permanent containers. Permanent containers are pretty much just like web servers that run all the time. For example, we have our workflow scheduler Apache Airflow, which needs a PostgreSQL database. So we use Docker Compose to run both of them together. Then we have Minikran, which is Andrie's package, who will be talking later on. I appreciate that package a lot. It helps us to distribute our own internal packages, but also to keep versions of cron packages in check or at bay. And this is really great. For the same reason, we use a custom Docker registry, which is also inside a Docker container, and then we use it to expose several kinds of API, and depending which team, which people build them, and these are maybe based on our technologies, maybe not. A more Docker-specific thing, though, is the non-permanent containers. We have universal images that we use for several kind of tasks, and then we have task-specific images that we use for tasks that are a little bit uglier to set up. So, for example, LaTeX-based reporting and so on, but I think I can explain it a little better in the application example later on. Then the second component is GitLab CI, which basically does the same job that GitHub Actions does for Marcin. We trigger on a Git event, like the push to the default branch. We build and test our packages, then we push it to our Minikran. we deploy it to our RStudio servers, and or in a simpler thing, doesn't have to be always an entire package production. We push files to our Docker host and then execute these R task files in a Docker container. You could, in theory, also go and build entire Docker images. We don't do that at the moment in production because we want to avoid lengthy pipelines, but we are very intrigued by it, and we'll soon do that. In code, this looks kind of easy to understand. We have 3 easy steps. We build and check the package, then we move it to our KOF custom CRAN, and then we deploy it to our RStudio servers. And as you can see, we're just using an off-the-shelf Tidyverse Rocker project image, and then build the package, and then SSH to our server and install it from our own mini CRAN. The third component that we have in here is certainly the smallest in terms of popularity, but it's already quite popular with us. It's Apache Airflow, and I'm learning more and more companies starting to use it. There will be Apache Airflow Summit next month. It's also a free online conference, and I think it's a growing technology. What do we get from it? We use it as a workflow scheduler. It's basically cron jobs on steroids in the first place, but it also provides us with a really nice GUI, and you can see that it lists all the tasks. You see the status of the task, the last few runs. You can see a statistics, whether they have been successful or not. So you get kind of a GUI component, which involves, again, other type of people, which is nice. And then to define the task and the sequence of the tasks, you simply write Python code, very simple Python code, and this Python code gets rendered into a so-called directed acyclic graph. This is what you see down here, and you can see immediately which tasks get executed sequentially, what is in parallel, and so on. So you got this GUI component, dashboard component, in addition to the cron job thing. And then you can trigger processes locally on the same Docker host. You can trigger it on remote VMs. You can start Docker containers with a Docker operator, and you could even run it on the grid using Kubernetes operators and so on. So how does that look in application? We have a very simple to understand project. It's called Swiss Data. What it does is it gathers data from various public sources and then transforms these heterogeneous data into homogeneous time series formats, read it into our PostgreSQL database. So this is what Swiss Data is in a nutshell. And this is what the DAG looks like. Very simple DAG. It's linear, it's sequential. First thing that we do is what we do in R. We download the data using HEDR and all of these packages, using a lot of tidyverse to format ugly spreadsheets that the public outlets providing us with, and then stored it to a text file, and finally use that text file, that tidied up text file, to store stuff in our database. Again, we use R as a database interface layer here, and then we once we have the data in the database, we are doing some post-processing, which is very stat-specific, seasonal adjustment, for example. So again, we are happy to have a stats language at hand. And as you can see down here, look, these last 2 lines of code, that's how you arrange the downstream, upstream thing, the sequences, what runs in parallel, and so on. So it's really simple, really straightforward with Airflow. But let me zoom in a little more to the operators right here to the specific tasks. So what you can see here is a task-specific image. Swiss Data needs a lot of packages to deal with a lot of different data formats. So we decided to have a task-specific image. We mount a volume to store the output. And then what happens is the moment this is nudged by airflow, the Docker container is started and immediately it gets to work and dies once the task is done. As opposed to that, standard image and the task file looks a little different. We got our basic image that can do multiple tasks. We provide it with a basic user. Again, we mount volumes, this time for the input, and we mount a second volume where we have a lot of task files that get updated by our GitLab continuous integration stuff. And then, yeah, we provide it with a database password. So inside the Docker container, database operations can take place. And then we simply say with this command which our task file should be executed in that Docker container. So this is basically a simple ETL type of project, which we happily run twice a day through our production environment with the stack I've just described. And R plays a very, very important role. So what does R exactly do for us in this? First of all, it manages the dependencies with Minicron and the package structure itself. Then it does the actual work like downloading, reading, processing the data. And I've seen hardly any environment in my 15 years in the business that has as many interfaces to such a bunch of exotic data sets and so on. And then we use R as a database interface layer as well. We use our custom package time series DB, which is receiving a major overhaul at the moment, and which I will present at R in official statistics at Euros at the end of this year. So is R any good at this? Well, for dependencies, there's also some dependency management. There's also some criticism. If you talk to the people behind Rengen, Alex Bertram and company, you will also see the downside of our package management. But we felt we could mitigate some of its weaknesses by Docker, and it's yeah, it worked reasonably well for us. We are kind of happy with it. Then, yeah, as I said before, R interfaces incredibly well. There is an R package for everything, and when they come up with an ugly data format or something new, R can handle this. I bet there's an R package as soon as the format comes up. Then, last but not least, what's important, it's been said so often, R is super inclusive, and especially in academia. This is important because we are dealing with a lot of Home Depot type of code. And that means researchers come up with the code and we turn their ideas into production. And is this really important for us to be able to have a language that is close to them, to use this language in production? I think R is great. It's just great at handling the people that even don't use it or even don't like it. And there's so many approaches to onboard these people, and this is very important. And R does a great job of bridging the gap between the researchers come up with the ideas and the production team that we are. So yeah. Last but not least, I want to share a couple of resources, because you can never say everything in a 15-minute talk. And yeah, I just also want to use the opportunity that I have here to thank the e-Rum people. What you've been done is pioneering. As Henrik said it better than me, it's really monumental, and I cannot really imagine, especially being one of the guys who's putting up UseR for next year, what it must mean to do all this and then get hammered by this crisis. And thanks for the great pioneering job that you did for the community. That's it for me. Thanks for listening.
Matt, thanks also for the nice words for the organizing committee. I'm sure they are very well appreciated. Okay, so we can now move to the next speaker. Actually, there will be two speakers, André Rivenæs and Markus Mortensen, which are two data scientists at PwC, and they work as, of course, a data science consultant in Bergen in Norway, and helping their clients to build and implement machine learning models. And they will be talking to us about XGBoost and how they integrated the XGBoost into creating a new banking product.
Hello.
Hi. How are you? Good?
Hi. So I'm André, and this is my colleague, Marcus.
Welcome. Can you try to share your screen?
Yes.
Okay.
So
let's see. Yeah, we can see it. Okay.
Okay, that's good.
Okay, you're good to go. The stage is...
Okay, thank you. So today we will be talking about using XGBoost, Plumber and Docker in production to power a new banking product, and we will provide some of the key takeaways we have learned during using an R model in production for almost 2 years. So the plan, first we will talk a bit about the product and the infrastructure. Then we will talk about how to make credit decisions using machine learning in R. Next, we will talk about how to actually make that R code ready for production. And finally, how to deploy that R code to production. So let's start with the introduction. So Buffer is a product by Sparebanken Vest, which is one of the largest retail banks in Norway. It's a fairly new product. So basically how it works is that it gives companies credit based on their outstanding invoices in real time. So we connect to their cloud-based accounting system, we analyze it using machine learning, and instantly give them a suitable credit based on their accounts receivable. So whether they should get a loan and how much they should get is decided by a program written entirely in R. So the architecture. So we have some external data sources, such as credit ratings per receiver of an invoice, and we have the cloud-based accounting systems, where all of the information about the invoices is stored. And this data is collected by an orchestrator through APIs, and the orchestrator will aggregate that data and send it to the decision engine. And this is where the magic happens. So the decision engine is written in R by the team, by us actually, and we make automatic decisions on whether or not to give credit to the customers, as well as continuous calculation of credit. So when that credit is calculated, the customer will get the credit available in his bank account immediately. So let's go a bit more into detail about how to make these credit decisions using machine learning. So this is the timeline from an application to a loan. So it starts with the customer applying, which is very fast. He only has to connect his cloud-based accounting system. Then the data is collected from the system and saved in an Azure database. Next, the orchestrator will trigger the first R API, which is a Plumber API. And then the invoices will be analyzed using machine learning, or XGBoost in particular, to calculate the probability of an invoice being paid. And that probability is then saved to a database. Next, the decision engine, which is another R API, is triggered. The decision engine basically aggregates the expected value of the sum of the invoices for the client, and also does some additional calculations, such as looking at the risk of fraud and the concentration risk. And together, these calculations provide us with the information we need to say if the customer qualifies for a loan and how much they get. And finally, the customer will get an offer for a loan. And all of this happens within seconds of finishing the application. So we actually don't just evaluate the customer at the application. We actually recalculate the credit continuously. And this is one of the most innovative parts about the Buffer product. So what happens is that when a customer sends a new invoice, say for 100K, we will analyze that, calculate the probability that it will be paid, and we will immediately give him an available loan for, say, 70K or so, based on the probability of it being paid. And that is done using XGBoost. So the APIs will be requested or are requested hundreds of times per day for unit scoring. And all of the invoices are also rescored in batch each night in case something has happened with, for instance, the receiver. The receiver could have gone bankrupt during the night, or anything could have happened, which might affect the probability we calculate. So we now have a few 100,000 invoices in the database, but as the product grows, we might have millions of invoices. And we have to be able to handle that. So far, the stress tests we have done prove that R is up to the task. The engine is able to handle the big data. So what problems have we had to solve when using R code and machine learning in production? Well, first of all, the code should be memory efficient and fast. If the customer has to wait too long, we could easily lose their interest. Next, reproducibility is essential. We have to be able to show how we calculated a given credit limit. This is due to regulations. They could come back and say, why did that customer get that particular credit? And we have to be able to show that. We also strive for 0% downtime, because having downtime can result in unsatisfied customers as well as increased risk for the bank. So when we update our models, we don't want the product to be down at any time. We also need to have control over dependencies. It would look very silly if the entire product has to shut down because an external package is updated. Finally, it should also be easy to integrate the R code with other applications. So how do you make this R code production ready? One of the most important things to think about when creating production ready code is which packages you should use. So for instance, a lot of people discuss should we use dplyr or data table. We definitely recommend that you use both, but depending on the situation. So in a production environment, we prefer using data table because it's faster, particularly on big data. It's also more memory efficient, and it has 0 dependencies. So we strictly use data table in production, but we do use the rest of the tidyverse packages when we do explorative data analysis and reporting. So in production, we also use the future package, which is really great for parallelized computing, which can really help you speed up your code. We actually do use one package from the tidyverse in production, which is per, which I think has some really elegant functions for handling errors, for instance, such as a safely function. We also use the tidy models package a bit for exploring new models and testing hypotheses. It is really great for that, and it has some great packages for tuning hyperparameters, for instance, as well.
Okay, so we have structured our code and solution into several R packages. And this helps us solve some of the challenges that André mentioned earlier, and it also gives us some other advantages. One of them being that the R packages have a really well-defined structure. So we know that the R function should go in the R folder, data in data, and so on. Also, as André mentioned, a big part of our job is to do analysis and make reports. And then it's really neat to have an easy way to use functions and data and models across from different packages. So packages also have a great framework for testing and documentation. We are using the teststat package for unit testing our code and the Roxygen2 package for documentation. What's special is that our package is never going to be published publicly. So the documentation is not aimed at the regular R user, but rather it's aimed for ourselves to make it easier to develop and maintain the code. So a part of an R package is metadata. We are using this to keep track of our package dependencies so that we always have the correct packages installed and also keep a consistent namespace. Also, we are using the package version to keep control over our model version and the state of the rest of the code so that we can easily go back in time to see why a customer got that specific loan at that point in time. So let's move on to our deployment process, where we have used Docker, Circle CI, and Kubernetes. As I was saying, we are develop and release improvements quite rapidly. We are doing some bug fixing and retraining our models. So it's very important for us to have a robust and deployment process which requires minimal effort. We would like to use our time to develop and not deploy new changes. So when we have some changes that are ready for production, we commit and push to GitLab. And this then triggers a Circle CI process, which is our continuous integration tool. This orchestrates the building of our Docker image. And in this, so when we are building the Docker image, we start by choosing a base image that contains the R version of our choice. And then we install all our package dependencies like data table and perf, for example. And then we build and install our own R package. And we also prepare our Plumber API at this point. And also, at this step in the process, we are running our unit tests again. And we obviously do this locally as well before we push to GitHub. But by doing it in this step as well, we are sure that our code works in, if not the exact same, very similar environment that our model is actually going to be hosted in. So if a unit test fails, then we get a notification and can start debugging. But if everything is fine, then our Docker image is pushed to the Azure Container Registry. Here, Kubernetes deploys our, at this point, Docker containers to the environment of our choice. So in this case, production. So Kubernetes is our container orchestration orchestrator that deploys our containers with specified CPU and memory. And it also has a really nice autoscale feature, which means that it will add or remove instances, and that is APIs, according to the traffic. So, as I mentioned, we are using the Plumber package to convert our R functions into APIs. And on the left, you can see how few lines that is actually necessary to do this. In the screenshot, you can also see that we have added a logger function so that we can see and have a log over what requests are being made against our API. On the right, you can see our structure in all of our packages. So I guess many of you are familiar with the R and data and the namespace and description and so on. And these are just regular or normal ingredients in most R packages. We have also added a source folder, which contains the file you see on the left, which is the file that actually creates the APIs, and also our Docker file and just a small entry point. So this is actually not a part of the package itself. So so to sum up, this combination of Docker, Plumber, and Kubernetes is a great way to deploy machine learning models and R applications into production. Previously, we used a virtual machine to host our models, but now, using Docker and Plumber, our lives has gotten much more easy. So one of them is obviously the deployment process. That was kind of painful before. Now it happens very easily. And also we have much better control over our dependencies and versions. So the illustration to the right shows how our Docker images are built. So we start with some Debian image, some Linux variant, add the R version of our choice, and also the dependencies and the versions of the packages that we would like before we finally just add our own R code. Also, the system developers in the team that are responsible for Orchestrator are really happy that we are now able to expose our model as an API, because it's much easier for them to just trigger a simple API request than running it on a virtual machine without an API interface. So Docker is also really great for the setup phase, because you can develop and test locally, which means that when you have a working Docker image on your computer, it should also work on your colleague's computer, and also in any environment you would like. So, for example, test environment and production environment. So you don't have to deal with the problem, it works on my machine anymore. Kubernetes is also allows us to have very little, or actually close to 0% downtime, even at releases, because instead of just shutting down an old version and then starting a new version, which gives us a couple of seconds or even minutes sometimes of downtime, it boots up the new version or some instances with the new version of our code and models, and slowly starts to redirect the traffic before it shuts down the old ones. So this was all we had time for. We would like to thank you very much for your attention, and we are obviously available for questions later, and you are also welcome to contact us directly.
Thanks a lot, Marcus and Andre, for the presentation. Very interesting work. Very interesting work, both from the scientific perspective and also the engineer one. Very well.
Thank you.
So we can move to the next speaker, which is Andrie De Vries. Andrie is a solution engineer at our studio, and I think Andrie is also the author of R for Dummies. I don't know if anyone has been reading it. Andrie would be giving a talk about creating drag and drop Shiny application using sortable. Hi, Andrie, welcome.
Thank you very much. I'm just checking that you can see my screen.
Yeah, I can.
Okay.
I can.
My video should be all right. There we go.
You're good to go.
Okay. Well, thank you very much. It's a great privilege to be part of this conference. I'm going to talk briefly about a package that we have called Sortable, and it allows you to create drag and drop experiences in Shiny apps, and also tutorials in LearnR that can have drag and drop behavior. So what's my motivation for developing this? And really, I'm at the moment, and I've been doing this for almost 2 years now, I teach an online course on R administration every month. And as part of that course, I want students to have their own continuous learning and feedback cycle, which means that they need to be able to answer questions themselves easily. And one great way of asking formative questions is a ranking question, where you effectively give somebody all the answers on a page, and their task is to order these in the sequence that makes sense. So what do you need to do to ask ranking questions in LearnR? Well, I want to be able to drag, and of course I want to be able to drop, and I want to do that using custom question types in LearnR tutorials. So that's simple, right? Just combine all of this, but the question is how. And when I set out looking for this, I found some work that somebody else did previously to wrap a JavaScript library called sortable.js into an R package. And we took that work by Kent and Russell and developed that further. And this package is now on CRAN. It has been available on CRAN for several months now. So let's start by a quick demo. So here's a tutorial in LearnR. It asks a simple question. I have some insects, and your task as a student is to drag those in a specific order. So I'm sorting some answers here, and then I click submit answer, and it tells me that's not correct. So let me try something else. Just try that again. Dragonfly, cricket, bumblebee. Yeah, maybe it should be ant, bumblebee, cricket, dragonfly. Maybe that's the answer. And there we go. Now it is correct. So this is what it looks like inside a tutorial. But what is the code? And the entire code for creating that tutorial is just these 10 lines of code. You call sortable inside your tutorial. You create a list of answer options. These answer options will be automatically scrambled. And then I call question rank with some instructions and the correct answers and some hints. And that really is all you have to go and do to create a ranking question type in a tutorial. But maybe you want to use this also in your Shiny app. How can you do that? And the simplest way to do that is to use a built-in function called rank list. And rank list allows you to do something similar. And here, it's not a very interesting app, but it shows what's happening. You can see I have options at the top that I can drag and drop. But at the bottom, I'm just printing the value of the resulting vector. So it starts out sorted, 1, 2, 3, 4, 5. And then I can drag 1 to the final position. And notice now that 1 is now in position number 5, exactly as I expect. And you can imagine that you can use this output in your Shiny app downstream for some other task. So how do you do this? Well, also quite straightforward. I first define some labels, in this case just 1, 2, 3, 4, 5. This is a vector or a list. And then in my Shiny app, obviously I load the sortable package. And then on the UI side, I call rank list. I give it some text and the answer options. And then I provide rank list with an input ID. This input ID is important because that will create a server-side object in your Shiny app that you can reuse. So what I mean by that? So on the UI side, I say create an output object that's called rank list basic, and through the magic of the sortable package, this input object will be available in your rendering functions. So that's really it. Did this work? Actually went one way. Yeah. So how does this work? Let me help you out with a mental model about how all of this fits together. So the sortable R package itself is a wrapper around sortable.js, which is a JavaScript library that gives you this dynamic browser-side functionality. And the package provides an HTML widget, and you can use this HTML widget both in your Shiny apps and your Learn R tutorials. And the functions inside sortable that you can use out of the box include rank lists. Now, rank list you can use as it stands in a Shiny app, but rank list also forms the basis of question rank, and question rank you can use in Learn R. But there's more to the package. In addition to rank list and question rank, we extend rank list into a bucket list. I'll show this in a minute. And a bucket list is also then extended into a question bucket. So, and again, so you have these different functions that you can use out of the box in both Shiny and Learn R. Let me show you an example of a bucket list. So on the left-hand side, I have the rank list that you've seen before. So I can change the order. And that's all fine, but I can also drag items from the left to right. So if I drag all of these to the right, and I can change the order here. Unfortunately, I can actually scroll down a little bit. So on the output side, you can now see that I'm capturing the value of both vectors. So I know my Shiny app is aware of what is in the left-hand side rank list, as well as what's in the right-hand side rank list. I can also drag items back, so I have complete back and forward, any which way you want. And all of this is now available in my Shiny app. Okay, what else should you know? Sortable is more than just these few functions. It's also a framework. And the package itself wraps around sortable.js. So anything you can do in the JavaScript library, you can actually also make available to your Shiny app. In principle, you can make anything in a Shiny app drag and drop. So that means you can use that using a low-level interface, do sortable.js, and then we show an example implementation in the package itself, and also in examples downstream on the package.down website. So you have many other options. Sortable.js allows you to define multi-drag items, so you can select more than one item before you drag those. Or you can define swapping behavior. So if you drag item 1 to item 3, those will in fact swap rather than insert. And you can define shared lists. You can clone items from the buckets. You can delete items from buckets. You can control the put and pull behavior. So you can control whether a list will accept elements or whether it will release elements from that list. And all of that can be done dynamically, including in JavaScript. And we have some simple wrappers in R to access that JavaScript. So let me show you some penguins. This is an app that uses almost none of the pre-built capability in Sortable. It's all custom, but you'll see some of the behavior here. So you can see that I have a list of variables on the left-hand side. The data is from a beautiful package by Alison Horst called Palmer Penguins. You may have seen this recently. And now I can drag elements from my variables into X or Y or color. And I've dragged island, and I want to analyze the bill length of these penguins on these islands. Ooh. Go on, I was expecting something more interesting to happen now. In the age-old tradition of demos, this is not working. I'll try and fix this immediately afterwards. The intention here is to show what the sortable behavior shows. Unfortunately, the plot behavior doesn't show up. You can see that I can drag and drop elements into buckets. And then you'll have to imagine right now that I'm actually using this downstream in the Shiny app to control the plot that happens. Let me just see if I press F5 on this, whether it makes a difference. I'm just hoping to force reload that app. There we go. Managed to save it. I just reloaded the app. So I'm analyzing bill length by island, and if I want to include the species in colors, it will do that. And if I then want to do a completely different plot, I can do that. And as you see, I can drag and drop elements to and from my different lists any which way I want. So hopefully this gives you a sense of the type of activity you can do with a sortable app. One thing I also want to show is that if I've told Sortable here that it's not allowed to accept more than one entry into X, Y, or color. So if I try and drop another variable in X, it doesn't accept that. I have to make space first for that to happen. So hopefully that gives you a sense of the type of application you can build with Sortable. So in conclusion, and I'll wrap up slightly early, is that you can use Sortable to create rank lists and bucket lists objects in your Shiny apps. This comes out of the box. You can also add ranking and bucketing questions in your learner tutorials. Again, this is available straight away. And you can then create your own complex drag and drop behavior in your Shiny apps using the lower level functions inside Sortable. I'm sure somebody's going to ask me, where are the slides? The package is available on GitHub, but it's also available on CRAN. And I have links here to the rendered version of the slides as well as the source version of these slides if you're interested.
Andrew, for the talk. Very nice talk. And so I guess it's now for the panel discussion. So I would ask all the speakers to come on stage, and while they are coming on stage, I will just go for a round of applause for all the speakers we had. Thanks a lot, guys. Very extremely nice work. Really impressive. Okay, so I'll just start a little bit off with this panel discussion, and also I'll try to stimulate on different kind, because in your discussion you really touched upon the use. Many of you touched upon the use of Docker, which I think it's an extremely interesting tool, really, to actually make production code, and I think that we should all really start to use Docker rather early, because I think it was one of the point of Marcin that said, start early to get things fixed. Also because then you can use Docker in the process, which really allows you to scale up in the application, as Andrea shown, and also really structure your application in a nice and neat way, also given the dependencies that also Matt was talking about. So I think it's really like one very good suggestion for all of us to really start to use Docker really early in the process. So I'll go just through some of the questions. There are really many, I must say. So I'm sure we won't be able to cover all of them. So please, for the audience, if I don't cover your question, please get in touch with the speaker straight away after the talk. So maybe we can start with Marcin. If you can actually shine some light on different topic. So what would you say is the normal optimal size for a team collaborator on our project? And how do you manage the library calls, especially the sequence in which they are called? Is there anyone in the team authorized to call the renv function and install the update packages? So there are quite some points. If you can just touch a little bit upon them.
Okay, I will go quickly through them. So about the size of the team, I would say that there's nothing such like a normal team size. I work in the efficient teams of 10 people on our project, or 2 people. But yeah, I would highlight that at least 2. It's very recommended, because then you can do the code reviews together, discuss the implementation. So this is really helpful. So even if you're working alone, it's good to find someone to briefly go through it, or for example, just for a code review, like half an hour a day. About this, who is authorized to update the renv and packages? I think it is connected, because it's always every team member, but this is also a power of the code reviews, and that renv log you are just committing. So when you have a pull request, the other team member will just review also the changes in the packages, because it will be clearly visible in the renv log. So what changes, and it can point out that, okay, we don't want to use this new version of the package because it is crashing something. Yeah. So this is also a great feature of renv. And it was also a question about the library calls. Yeah, they can influence the behavior. So a good pattern is always to mention the package name that you are using before the function. So you have a package ::, and then the function name, and so that it's clear what function you're using.
Okay, thanks. I would move for a question for I think was Matt, that can Airflow be easily used on cloud instances while having a centralized dashboard of all workflows?
Well, I'd say yes, but I'm not entirely sure whether I got that question correctly, because I mean, Airflow in itself is not very demanding resource-wise. You simply have it as like the control panel somewhere, and then it triggers. You can connect. Then you have certain operators like an SSH operator, which is where you can just connect to any remote machine. Then you got specialized operators where you go to like a Docker container, like a Docker operator, or a Kubernetes operator where you can fire up an entire grid. You could also work with Docker Swarm, all of that. So it's like a tiny control thing that doesn't really take up a lot of resources. And of course, you can run it inside Google's Docker engine. For us, Airflow itself is really running in a simple permanent Docker container on a machine that doesn't have a lot of resources.
It makes sense. I actually had one question about Airflows, because I haven't been quite using Airflows together with R. I kind of used it sometimes together with Python. I know that there are some Python. Well, the API are in Python, but you used it like integrated with R, or?
Yes, exactly.
How do it work?
We are just using R inside Docker, and we're using all sorts of Docker images, custom Docker images, off-the-shelf stuff from Dirk's Rocker project, Plumber APIs. We're just using it, and the good thing for us is we got people that use a lot of R, and we got people that rather work with JavaScript. That's why I made this remark in the beginning. I think a good benchmark for that thought is really think about Shiny. Think about how popular Shiny is within the data science community and within, as opposed to outside of it. And then you see that we are in a separate ecosystem. And if you want to work with other engineers, then bridging the gap is incredibly important. I had a very interesting discussion with Alex Gold from our studio about this when he gave his Shiny talk. So I think this is the key there. I think of course DAX and everything. This is in Python, but essentially it's language agnostic, so to say.
No, but I meant like the integration with the Airflow.
Yeah, you use R inside a Docker container, and you can. We have a Docker container, and that I think the interesting use case is where you don't have the task-specific image that fires up immediately once the Docker container is fired up. But you can have an R file that sits somewhere. It doesn't have to be a package, and then run that file within a specific container. And this is what we do, and Airflow just triggers that.
Yeah, sure. Okay, maybe we can move to André and Marcus. There are quite some questions, so I'll just go with some of them. What do you guys do to control the overfitting, since your predictions directly affect the sampling population, right? Okay, affect the sampling population. I would assume that he refers to the possibility that the customer might change his behavior due to our calculation. For instance, that he sees that the invoice will not get a high credit, and he will change the behavior based on our calculation. We have explored that hypothesis, and we have not seen any signs that the customer's behavior is affected by our calculation. That's a really good question. Yeah, then I also see that there were some questions from Matt. Maybe, Matt, you can just pose the question yourself, I guess, since you're on stage.
Which question do you refer to?
Well, to André, and maybe also to André.
You mean the question for André? That was how is your you have an interactive example. Shiny apps mostly are just interactive presentations of stuff, but you have something where you really collect content. What is your approach on for storing the content? How do you do that? And post API, is it file based? What do you recommend?
Got a question for me?
Yes.
Okay, yes. That's a great question. Yes, I use Shiny extensively for collecting user information. I have surveys pre and post my training. I also collect telemetry directly from the virtual machines where people run their analysis or their installation. I collect that information. And yeah, generically speaking, you have three ways, I think, of storing that data. Either on a file, typically you'd want to do that on a shared file system, probably. And your simplest way to do that is write.csv. It's standard R code to write to a shared file that you have access to. Your second generic mechanism is to write directly into a database. I use that a lot. I use dplyr or simply dplyr code that makes a write operation into a database. dplyr wraps very conveniently around that, and if you need to take specific control of your database, you can use dbi to do an insert query. Now, the third generic way, somebody asked in the question, can you use an API to post somewhere? Yes, certainly you can, and all of those are possible. The exact mechanism you use, I think, is going to depend a little bit on the level of complexity you want to take on, which is also going to be directly related to how important this data is. So, for example, I routinely capture information and then use the Google Sheets 4 package to write that information into Google Sheets, just append the row at the bottom. But for data that is high frequency, I went to the effort of writing directly to Postgres or the database of choice. Yeah.
Maybe one short follow-up question. Do you have to do anything to take care of like concurrent requests when you just have a couple of people with Shiny? Because I think this would be interesting to a couple of people. Do you have to do something, or does it get happen out of the box, especially when you just append to files?
You have to take some care when you append. Especially if you write directly to files, then this is a danger zone where if you have multiple appends to the same file, you may run into problems. So that's something you want to be careful about. As I mentioned, if I write into Google Sheets 4, that's an API call, and Google Sheets takes care of that for me. So I never have to worry about concurrency there. If you're writing to a database, again, most databases, especially transactional databases like SQL and the most NoSQL databases as well, will take care of that concurrency. The consideration you then have is if you have a lot of users concurrently, you may run out of database connections. And there is a package called, it's not called Pool. Pool, not Pool. Pool.
Yeah, it's a Postgres thing, right?
Well, it's not Postgres specific. The Pool package allows you to share database connections in a pool of sessions. So rather than every process using its own DSA, it shares these sessions amongst the pool of users.
I know that feature from Postgres, but you're saying this is an R package, right?
There's an R package called Pool. It's available in CRAN that is, I believe, database independent. Yes.
Perfect. Thanks.
Guys, I think I have to go out from the session because the time is almost up, and also because I will be moderating also like the thematic lounge, which today is about data science and business, which I think is actually something that is quite relevant to you all. So if you have the time to have lunch with us, you're all very welcome. So we will be a little bit talking about what it means doing data science in business. But I would like to really thank you all. But if you want also to continue the discussion, you can also for the open lounge, where you can also chat with all the attendees. I just go again with a round of applause for everyone. Thanks a lot. Thanks a lot, and have a good day. See you around. Cheers.
Thanks very much, everybody. Have a great day.
Thanks.